Thank you very much. I hope that everyone will hear me. Yep. Everyone last. Okay, great. So today I will present very practical presentation about the fine-tuning large models. And this case will be specifically about the data to text generation that was connected with our project in our company. I'm working in Texas for our large customer center group and working with the US e-commerce project. I'm Master of Science in Computer Science, graduated in Transport on Sakharov Institutes. And I have a quite extensive experience in software engineering as well. And our last 4 years working as a lead ML engineer and leading small team of 3 people, including me. But we're making interesting projects, and today I will share one of them. So I will start with a brief introduction about the LLMs and how we can fine-tune them, what kind of libraries we're using, and it will be like a more generic topic. And then I will dig into details about the data to text generation and specifically a bit talk about our business case. And then share basic conclusions, and then you will have able to ask your questions if such. So starting with the fine-tuning LLMs, I would like to make clear about a few terms, because when we are working with the ChatGPT right now, we usually do like a learning, but this learning is a bit different. It is like call it zero-shot learning, when we are providing the query or question to the ChatGPT and getting an answer. But then we are able to provide a few examples, and then we are making the one or a few shot learning. And this is like a capability of very large models. Unfortunately, not always we're able to use them. And specifically, if your company is worried about the security on any kind of risk, then you're starting to think what kind of solution it might be. And then we start thinking about the fine-tuning our personal model inside the company. Under fine-tuning, we usually understand the adjusting the weights of the large linguistic model using some training data. And there are different concerns about when we should start the fine-tuning the model. And one of them, if the prompt engineering actually doesn't work for you, and you find out you spend a lot of time making a lot of prompt engineering and find out that it doesn't work, and you would like to get much more clear result, much more better quality of your text, and then it is not an only option that you should consider. Another one is the very hypey right now, that is retrieval augmented generation, or RAG. When we are making a very complicated system which working together with any kind of cloud APIs, getting the information into this cloud and get back the results, searching into index database, vector database, and you might even find that even such options might not work for you. Then you start to consider, what if I fine-tune my model? But the main question, do you have enough data for this? Do you have actually the data available to train the model? Of course, the fine-tuning doesn't require a lot of data, much less, and I will describe how much data you need. But let's imagine we have this data, and then there is a common costs. The cost of engineering, the cost of compute that you require to fine-tune the model. You should consider everything of this. And let's imagine we're ready, we would like to start to fine-tune the model. But there is another one major concern, how to measure the results. And it is the actually real problem, because in our case, we spend a lot of time to measure the results, and we're still measuring. So let's compare the fine-tuning with the pre-training. So you're hearing a lot about the training the models, but actually fine-tuning is not comparable with the pre-training when we are getting the like a huge model from any kind of providers like Meta, Google, or OpenAI. And for example, pre-trained the model is uncomparable complicated task. You need a weeks with a huge amount of compute, thousands of GPUs, terabytes of data, and there is a budget which starts with the millions. But when we are considering the fine-tuning, we can fine-tune the model in hours using only one GPU, even consumer GPU. And the data is about 100 megabytes. There is or 1,000 examples for training data. And there is a small budget that can have any company actually. And what the difference between the pre-training and the fine-tuning? So when we are pre-training the model, and it is actually happening in big tech companies, what they actually do, they are getting the terabytes of very qualitative data, which is impossible to get for the small company, and then making these so-called unsupervised training. How it happens? So we are getting any kind of data, text data we mean, and mark these some words, and then the training process forces the model to guess these words. And it is how the unsupervised training works. So we don't have any labeled data because it is impossible to label terabytes or even petabytes of data. And then we are getting this model. So we, as a small companies or even consumers, we can download this model from providers such as Google, in any Meta or any other providers, and get any small amount of examples, label them, and make this supervised training. And then we forcing the model to answer some specific question with some specific answer, or generate the text that you would like to have. And fine-tuning actually might be different, and the most straightforward approach is this so-called full fine-tuning, when we actually take the model and continue the training it in the same compute, having the same GPUs, but using some existing checkpoint. Unfortunately, it is not always possible, because for some reason it might require an enormous amount of compute. Yeah, and scientific community find a way how to make it happen on even one GPU. And you can use the parameter efficient fine-tuning when we are not adjusting all the weights, we are still having this freezing state of the model, but adding the new weights inside the model and adjust only those small part of these weights. And there are two approaches. One of them is LoRa, which basically adding the layers inside the model, and you're training those small amount of layers instead of adjusting whole the model. And the interesting way is the prompt-based methods, when you are creating some kind of soft prompting, which is differs from text, but we will not dig into details how it works, but you have to keep in mind there is some methods that might help you to avoid the using a large amount of compute to fine-tune your model. And of course, if you start to think to fine-tune something, you should get some open source LLMs. And first consideration, it is about the license, because not all the licenses allow you to use these models for the commercial needs. Then you should think about how large this model should be, because when we are taking the larger model, it comes with better capabilities, but unfortunately with the cost of requirement for large amount of compute. Another one important aspect is context window. if we are getting the larger context window, we're able to put more information inside the prompt, and then we're able to process more information. And in most specific use cases, it is very crucial. And for now, I selected two most attractive models right now. The Mistral, recently released by the small scientific group, and become quickly popular because it's beat any models in leaderboards and having very interesting technical specification. So it can get as an input about the 4,000 tokens. So we can send 4,000 words with some kind of sliding window, which extend this context window to 60,000 tokens with a very attractive license like Apache License 2.0. And probably this week released, if I'm not mistaken, the Gemma from Google, which has pretty similar technical specification, but unfortunately have very custom licensing, which you should consider and read carefully. But as far as I know, it provides also allows you to use for the commercial needs as well. When we have chosen the model, we probably have to have any kind of fine-tuning library. And right now, nowadays, we're not using like a deep learning framework for the fine-tuning the model. We're using some specific library which actually integrates into these deep learning frameworks. Today we have like two groups of libraries which integrates with the PyTorch, and another one small group from Google which use mostly JAX. When we are talking about the like a use case, when you would like to start with use something, I would suggest to start with the Hugging Face, probably the most known deep learning library provider, and it integrates with the Microsoft DeepSpeed. It might help in case when you would like to train very huge models and you have to perform data parallelization or model parallelization. So the DeepSpeed solves these issues. NVIDIA provides their own solution, but unfortunately not so popular as far as I know. And in terms of supported models, most of them support a huge variety of different models. Probably most popular right now is Llama, but Mistral is quickly catching up. And talking about the Google, because right now they are like having completely different direction, and they pushing forward their own framework named called JAX. And why I'm focusing on this framework? Because in our project we choose the Google, and I will share the why we have chosen it a bit later. So if you are not up to hacking and installing everything on your laptop and trying to like spend a lot of time on engineering, the great option is to fine-tuning the models inside the clouds. And right now, most of the cloud providers allows you to fine-tune the model. Very interesting group of cloud providers are Azure and OpenAI, because they are collabing and provide the ability to fine-tune the GPT. In case of Amazon, they have their, by the way, they have their own model, call it Amazon Titan, and also they collab with such well-known providers like Anthropic, Cohere, and Google with their Google Cloud Platform and Vertex AI. It's kind of stay aside because they mostly provide their own models, known as Palm. Probably right now it is most known and most capable. Gemini is currently recently released, and the interesting thing that Google tries to jump into open source market as well. So with their smaller version of Gemini, which calls Gemma. And most of the providers also works with the Llama. So Llama kind of attractive just because everyone supports them, and it's pretty famous in open source community. So another one aspect that you have to think of, it is what kind of hardware you will choose. Because right now there are two options for industrial needs. There is a GPU or CPU. There are a couple other variation, like you can use Cerebras or IPU from GraphCore, but I'm not covering this because it's kind of complicated and not so famous, so you can read by your own. Talking about the NVIDIA GPUs and the Google TPUs, what the major difference between them? First of all, NVIDIA is presented in all clouds, yeah, and you can even have your own GPU on-prem. Google unfortunately presented only Google Cloud, and it is the vendor lock. But with the same time, it comes with a very interesting thing, which is cost efficiency. In our case, we're choosing the Google TPU just because it is more cost efficient. It is twice cheaper, and you're having the same teraflops, and even in our case, it helped to fine-tune the model just because one unit of TPU might have up to 128 gigabytes of RAM, which help you to put one large model into one unit. And why it is important? It's important because you are avoiding to fine-tuning the model distributedly, because it is very complicated. If you are able to put the model into one unit, then you are avoiding this stuff. It is very, very complicated engineering task. And that's why most of the open source communities tries to feed the models into one laptop, Apple Silicon, etc. And going further, I would like to highlight a few other important topics, but unfortunately we will not be able to cover them. Inference performance. When you have created your model, you have to somehow deliver it efficiently and make the prediction with a low latency. And there are a couple of approaches, like efficient attention, most known as a flash attention right now, quantization by reducing the footprint, memory footprint, and mixture of experts, which recently shined thanks by the Mistral team, which decreased the inference time. Also, I mentioned about the retrieval augmented generation and probably well-known reinforcement learning from human feedback. Those both approaches give you ability to avoid the hallucination or any kind of misleading behavior of the model. Okay, that's quick introduction about the fine-tuning and what you should actually know. And then let's start to dig into details, and let's talk about the very specific task. This is one of the tasks, and as we know, most of the models right now capable to do everything. But the data-to-text generation, it is one like a specific task that they are able to do. And in our case, we start to think that we have a lot of use cases when we have to create the text from the structured data. And for example, to define the task for the model, we are getting some structured data, putting into large linguistic model, and we would like to generate the text which contain the same values that we have provided as an input. Looks very straightforward, but unfortunately it is not so. It doesn't work well for the open source models. And in our case, we took the model T5 from Google with the 3 billion parameters, which is quite a lot. Library T5X provided by the Google, which works perfectly, and specifically for their own models like T5. And we, as I mentioned before, we was able to fit this model into one single unit, into TPU version 3.8. Right now the latest one is 5th version, as far as I know, and this particular version contains about 128 gigabytes, which actually the largest amount of memory. Probably the only competitor is the Apple Silicon. And of course we chosen that Google Cloud will be our vendor lock, but we are not afraid of it because we know for sure that we might migrate the model on any cloud by just simply migrating to GPUs. Talking about the dataset was quite large, so 300,000 examples, and the rest, about 50,000, we left for the A/B testing. And in our case, we chosen the simplest approach without any extra modification of the model, just using the supervised way with the full fine-tuning of weights. But the question is why we have made such choice. And the interesting part of this project was that it was happening in 2021. And on that time, unfortunately, the most famous model was T5. And competitors was the GPT-2, which wasn't quite open source and had probably tricky licensing as far as I remember. So we tried different other options, the modification of the GPT-2 created by the open source community, GPT-J and GPT-Neo. And as far as you see, for example, here's the two scientific papers about the T5 and GPT-2, and you might see that T5 is still quite popular in the academia. So it is why actually T5 was our choice. But as far as I know, that it's not so famous in the engineering community. So what we actually had, so we was able to enlarge the model till the 11 billion parameters. There are such version, and as I mentioned, cost-efficient training using TPUs and thanks to JAX, which creates a very optimized compiled computational graph, and the licensing the same as a Mistral, so Apache 2.0. And yeah, unfortunately, Llama wasn't the option for us just because it wasn't released yet. So what the training task was, we took the structured data presented as a text. Unfortunately, just because of the way as we did it, we didn't use the JSON. We just put the pure text into input prompt and collected the examples what actually should happen. And in this particular example, I just presented the generation for weather forecasts. In our case, it was a bit different. Unfortunately, I'm not able to share it, but it was completely the same. So we presented some specification about the weather, for example, and generated the text using the 300,000 pairs for the training. What kind of problems we faced with? The major problem was the text that was generated. First of all, it wasn't naturally sounding it was not naturally sounding enough. And another one's problem was that in many cases it was too short, and we had the requirements to have the very long texts, and we have to influence the training somehow to make the model generated longer texts. There was quite a lot of errors, for example, wrong numbers, and I will talk about this specifically. Else model for some reason used some words that from our point of view was forbidden, and we should avoid them. So we forced the model to try to avoid them. And also there are like very classic errors, like model tries to repeat the same frames multiple times, many words was repetitive, and etc. So the solution was the simple. We simply changed the model from the smallest one, which was like 60 million parameters, till 3 billion parameters. And magically, model starts to learn better. Also, we changed the input data. And first of all, we cleaned it. We removed a lot of irrelevant examples. Also, we played with the prompt to force the model to avoid forbidden phrases. And also, we labeled some examples with the labels, call it like a low quality or too short. And I will show you how it helps to force the model to learn how to generate proper text with the proper quality and increase the length of the generated text. Another one important point is to cluster text and remove the similar, not even duplicates, but even similar text. Because if you're providing the text with like a few words was changed, unfortunately, model overfits on these examples and start to generate them often. So if you're providing very often the same or similar text, then the model thinks that it should generate those examples much often. So we applied the simple clustering with the local sensitivity caching and made the duplication of the texts. And here is the way how we regularize the model via prompting. So, for example, we would like to avoid the last phrase, "It is beautiful day to be outdoors." And we would like to text sounding more formal. So we mark those examples as less formal. And of course we have the same examples which sounds more formal, but we are not putting this label. And the magic happens when we are training the model. It starts to learn the relationships between the prompt, what we are inputting, and what it generates. And as example, when we need to generate the text, we simply remove the label, and the result, we are not having these words. And based on our statistics, we are creating multiple metrics, and one of them was that how many text doesn't have forbidden words. And it appears that larger models, with our adjustments, capable to learn that some particular words should not be included. And the same happened with the length of the texts. Here is the distribution of the length. So we see that larger model of T5 tend to generate longer descriptions. So results are following. Results of evaluation are following. So we created the custom metrics, and example is simple. So by getting the number of forbidden words and count them. And another one interesting metric that we tried to count unseen numbers. So why especially unseen numbers? So numbers, it is something simple what we can actually track via regular expression. We're just comparing the prompt. If, for example, prompt contains this number, then it should appear in the generated description. And vice versa, if the numbers doesn't appear in the prompt, it should not appear in the generated description. So we extract all the numbers from the generated description and count how much numbers wasn't presented in the prompt. And this simple metric just alert us in case if the model for some reason hallucinate, and we're able to track how much text have these types of hallucination. Another one step was the export verification. We took about 100 till 1,000 different texts, provide them to the expert. Experts said that it's quite well structured, it has good enough quality so we can use them in our internal systems. And the same thing we made by our own forces, so we just have well-known examples, we track them through the multiple experiments and track how they changes over time. And the last and very complicated step was A/B testing. So we performed the A/B testing, it still runs actually, and we proved that our generated text basically have a similar quality or even better in some cases. And our conclusion was the following. So LLM field right now is complicated, it's hard to get into it, yeah. But the most complicated part is collecting the data set, unfortunately. So engineering part was quite clear, and right now we have a lot of tools to make it happen. But the data sets, and specifically high qualitative data sets, it's the key to fine-tune the best models. And of course, to simply increase the better results and quality of the text, you have to use larger models. Unfortunately, it comes with the trade-off that you need to pay more for the compute and pay more for the ML engineers' time. And yeah, and the last, and I said that fine-tuning require a lot of very qualitative data, and that it is the key. Thank you. Thank you very much. Any questions are welcome.
What was the measures of A/B test? And do you
Right.
make an A/B test?
What do you mean under A/B test?
When you divide into three groups, and if you have two groups of kind of A,
Okay,
which,
I see.
No difference should be.
Yeah.
And
I see. Yeah. In many cases, we're using this AA approach. Unfortunately, in this particular example, it was complicated. And the reason why, because it wasn't the A/B test. It was comparison without the randomization. We used causal approach when we are tracking the changes over time, and we're trying to see the correlation between the two groups. It was quite complicated. There was a lot of metrics, and unfortunately, I cannot share the deeper details. In this particular approach, from my point of view, it is enough like splitting the groups into two. For example, we are showing the weather forecast for the one group and showing weather forecast for the another. If we are not able to split the group, for example, we are sharing them on the site and people are coming from Google, for example, for some reason we are not able to split the group, then probably our approach with the causal approach, yeah, causal inference, it is the only way how to do it. But it is completely different topic about the A/B testing and how we do it. So I can share after this. Q&A. Okay.
The question about models. So currently you were saying you had to use that model because other models were not available yet at the time. But if you do have all the training data, then basically you can very quickly now fine-tune some newest models and just see what works best for today, which could be much better than like year-old.
Yeah, that's great comment. Yes, exactly. And as I said, we are not worried about the vendor log just because we have the training set. We can take any libraries that I shared today, and they appeared recently actually, specifically about the Hugging Face. And we are able to just get this training data, put this into this library into cloud, use them, and transition all our efforts to GPUs and to any cloud or even on-prem hardware that we have as well. Yep.
Yeah. So you mentioned you took T5.
Yep.
2021, 2022.
Yes.
That's understandable. We took the same.
Oh, great.
Actually,
Great to hear.
The same models, like, yeah. But I was wondering, like, if you would do the same in 2024, what base model would you take today?
Great question, and there are a couple of options. So we might continue efforts with the FLAN version of T5. It's quite work well, but we have to review the benchmarks. Probably another one option is Mistral, because it's kind of very popular right now. It also showing great result on the leaderboards in Hugging Face. But from my point of view, there are no big difference from taking all these models, and I think that it is even worse, worth to start with in a kind of cloud fine-tuning and take, for example, Gemini. But recently, Google released their new open source model, which become more popular than any others, and it is Gemma. And Gemma works the best for any kind of cases. And I'm personally kind of biased towards the Google Cloud and the Google products just because of my experience. It works, and they usually release better products compared with the others, but unfortunately not so fast. They're catching up right now, and I believe the Gemma might become the most popular model nowadays in a year or two.
What's your personal opinion on the small language models like V2 or...
Which ones?
The small language models, like we call it, which are less than 2 bill parameters.
Okay, I see.
Base and then fine-tune.
It depends on the task. So if we are trying to make the classification or some simple task, then we can use the smaller models. Or we have very narrow task that model might be capable to train all these patterns, then probably the smallest model is great. But as I said, we have the path, these parameter optimized fine-tuning with the LoRa or quantization, so we can get these larger models and put them in even smaller compute. And I believe the next step, it will be that we will get the version of those models on our mobile phones. How it will happen, we don't know, but I believe they will optimize those models to upload it for the mobile phones. And then there will not be a question what kind of model. Why should we use the smaller model when we can have the larger ones? But it depends on the task, of course. Okay, anyone else? Probably that's it. Thank you very much.